Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, integers topic we are going to learn. So regarding textbook topic, we have learned some topics regarding the integers chapter. Let's continue the integers topic, somewhat extra content related to integers topic. So here, one minute, children. One minute. So in 19th century, these negative numbers were accepted. So integers means already we know, along with 0, we will be having positive numbers, positive integers on the right hand side and negative integers on the left hand side. Actually these negative numbers, they were accepted in 19th century. So the word integer was first introduced in 1563 by a man named Abermouth Holst. Abermouth Holst. So while he was doing an experiment, he found about this integers. So the word integer in Latin, it means untouched or undivided or whole. So like that, it is having so many meanings. The symbol for integers is Z. So positive integers are denoted with plus Z, negative integers are denoted with minus Z. The symbol Z is often used to denote set of integers. Actually, this symbol Z originates from Zahlen, which means number in German. So this symbol Z is originated from a German word. So Zahlen, which means number, So the name of integers, so they were named, these negative numbers were named as integers in 1563 by Abermouth Holst. Okay. So next. So here. One minute. Next here. So about all these properties already we have learnt. Those set of integers, how to represent them on the number line. So in the middle 0 will be there, right hand side positive integers will be there and left hand side negative integers will be there. So the set of integers we can represent in flower braces, dash dash, -3, -2, -1, 0, 1, 2, 3 and so on. Means highest integer we cannot tell or it do not exist, and the lowest integer also it does not exist or we cannot guess. Okay, about this closure property, commutative property, associative, distributive, about all these properties already we have learned in our previous videos. Okay, so let's go to next slide. So these are the revision of textbook topics what we have learned. So the integers means collection consisting of natural numbers, 0 and negatives of natural numbers is called integers. Means 1, 2, 3, 4 are natural numbers, 0 and these are negatives of natural numbers. This -1, -2, -3, -4, they are negatives of natural numbers. These are all. This collection is called as integers. Sometimes it is denoted by I, sometimes by Z. So -1, -2, -3, -4. These are called negative integers. 1, 2, 3, 4 are called positive integers. So here 0 is, it is neither positive nor negative. So here the collection starting from 0, 1, 2, 3 and so on is called collection of non-negative integers. Because here we cannot tell them as positive integers. We cannot tell them as positive integers because 0 is not neither positive nor negative. So that's why we call them as non-negative integers. Y means it is not having any negative integers. So that's why we call it as non-negative integers. So okay, these integers can be represented on number line. Regarding that, already we have learned. Any two integers can be added or subtracted. Children, if you are watching this video, so before this video, we have 5 parts of integers videos. Please watch that 5 parts. After watching that 5 parts, this concept you can understand. So this is the 6th part actually. So before understanding this 6th part, you have to complete this 1 to 5 videos. 5 videos you have to complete. So this is the 6th video. Okay, children. So next, here. So any two integers can be added or subtracted. So integers are closed, means they follow closure property under addition and subtraction. Means if A is an integer, B is an integer, A plus B also an integer, A minus B also an integer. So that's why they follow closure property under addition and subtraction. So addition is commutative for integers. Means A plus B and B plus A, same result we will get. So two numbers, two integers can be added in any way. Means they are commutative in nature. Not only two numbers, three numbers, three integers we can add in any way. So here AB are associated with each other, then with C. Here BC are associated with each other, then added with A. We can add in this way, we cannot in this way. The grouping may be A plus B or B plus C. But the sum of three integers is always same. We can add in any order. So this is called associative property. So integers, they follow associative property under addition. Under addition. Okay. So next. The integer 0 is said to be the identity element. The identity element under addition. Means for any integer, if we add 0, its identity does not changes. The integer identity does not changes. It will be equal to itself. It will be equal to A. So that's why 0 is called identity element under addition. 0 plus A plus 0 or 0 plus A equals to A for every integer A. So 0 is called additive identity. Additive identity. So not only identity, so every integer, it also has unique additive inverse. Unique additive inverse means whenever an integer added to its inverse, suppose 2 is there, plus 2 is there, what is its inverse? Minus 2. If we add plus 2 to minus 2, what happens? Total result will be 0. Total sum will be 0. Total sum will be 0. So whenever an integer is added to its inverse, the sum will be 0. So that's why here the sum is 0, which is additive identity. Here 0 is additive identity. So here if A is an integer, its additive inverse is minus A. Why? Because A plus A minus A equals to 0. Additive inverse of 2 is minus 2. Additive inverse of minus 4 is plus 4. Additive inverse of 0 is 0 only, because 0 does not have any minus sign, plus sign. So that's why additive inverse of 0 is again 0. So next. So under subtraction, these integers, they won't follow commutative associative property. They won't follow commutative associative property. Means A minus B is not equal to B minus C. In any order, we cannot subtract. Sum will be different. Sorry, difference will be different. Or 3 integers are there. 3 integers are there. We cannot subtract them in any order. We can, but the result will not be equal. So they are not commutative, they are not associative, and they have no identity element or inverse element. They don't have any identity element or inverse element. They don't have identity element or inverse element under subtraction. Because a minus 0 equals to a, but 0 minus a equals to minus a. Difference of 0 and a. Difference of 0 and a is minus a. Here we have taken a, but we have got minus a. So that's why in this case it may be true, but in this case it is not true. So there is no identity element, there is no inverse element. But integers are closed under multiplication. Means if a is an integer, b is an integer, their product c also an integer. They follow closure property in multiplication. So product of two positive integers always positive. Plus into plus equals to plus. Positive and negative is negative. Means plus into minus equals to minus. Positive into negative always negative. Or product of minus into minus, negative into negative, also positive. Means plus into plus positive, minus into minus positive. Means same sign multiplied twice, means positive will come. Or plus into minus, minus, or minus into plus also minus. Different sign product, negative sign will come. Next. So 12 to 15. Okay, still same points repeated again. Okay. This slide, we can delete this slide, no need. Okay, same points repeated. Next. Product of even number of negative integers is positive. Means minus into minus, positive. Because minus we have multiplied 2 times, which is an even number. Or minus into minus into minus into minus 4 times. Then also minus into minus plus, minus into minus plus, plus into plus, plus. Then also it will be positive. Means negative sign, if you multiply even number of times, 2 times, 4 times, 6 times, 8 times, like that, then product will be positive. Or if we multiply odd number of times, means minus into minus 3 times, odd number of times, minus into minus, plus, plus into minus, minus, then negative sign will come. Means if negative integers are multiplied odd number of times, then negative integer only will come. So multiplication is commutative. Means a into b equals to b into a. This is true. So that's why multiplication is commutative. So multiplication is also associative. So a into b into c equals to a into b into c. It is also associative. In multiplication, identity element also exists, which is 1. Means if you multiply a with 1 or 1 with a, answer will be a only. Answer will be a only. Next. So here, multiplication is also distributive over addition. It is also distributive over addition. This property is called distributive property. Means a into b plus c is there. here we have into, here addition, product and addition is there. This product can be distributed to B, distributed to C, means A into B. We can write plus A into C, means multiplication is distributed for both the terms or over addition. So this is called distributive property. Or if we have B plus C into A, right hand side we have single element, then also B into A plus C into A, like that we can write. Okay. Next, integers are not closed under division. So if integer is divided by another integer, we may or may not get an integer, because 12 divided by 4, 3 times 12, we are getting 3 as answer, which is an integer. But 11 divided by 7, it is not at all divisible. It will be like that only, 11 by 7 only, which is a fraction or which is a rational number cube, which is not integer. So if we divide two integers, may be an integer, may not be an integer. So they are not closed for division, or they won't follow closure property. They won't follow closure property. Next. Next children. Next, division gives an integer. If division gives an integer, then when positive integer is divided by negative integer, like 4 by 2, so then the quotient is, when positive integer divided by positive integer, plus by plus equals to plus 2 times 4. So result will be positive integer. When a positive integer is divided by positive integer, result is a positive integer. Means when the numerator is positive, denominator is positive, result will be positive. Or when a positive integer divided by negative integer, then the quotient plus by minus 2 times 4, then the quotient is negative. Then the quotient is negative. Quotient is negative. When a negative integer divided by positive integer, reverse, minus 4 by plus 2. Minus 4 by plus 2. Here also minus by plus minus 2 times 4. Positive by negative, negative only. Negative by positive, negative only. In both cases, the quotient will be negative integer. Whereas if we have negative integer by negative integer, negative cancel, the result will become positive. 2 times 4. Means during division, same sign is there, means it will become positive integer. For numerator, denominator, different sign is there, means the result will be negative. Result will be negative. Next children. So for any integer a divided by 0, is not defined. Why? Means in denominator place, if we have 0, that is not defined. So a divided by 0 is not defined. But a divided by 1 will be a only. Means if we divide by 1, any number, if it is divided by 1, same number will come. Or any number, if it is divided by same number, both will cancel. 1 will be the answer, where a is not equal to 0. Whenever we are considering denominator, we should take one assumption here: a not equal to 0. Denominator is not equal to 0. So here, division of integers, neither commutative nor associative. Means a by b is not equal to b by a, or a by b by c is not equal to a by b by c. A by B by C is not equal to A by B by C. Two integers, if the order of division is changed, numerator, denominator are exchanged, result also will be different. So they are not commutative, they are not associative, they don't have any identity element, or they don't have any inverse element like addition. Okay, children, these are the basics, children. Already these basics we have learned. Already these basics in our previous 5 videos we have learned. So please revise that 5 videos and then come back to this 6th video. Next, children. So the extension part, synopsis 1.2. So simplification of integers. Simplification of integers. So here topic is how to simplify integers. So when simplifying mathematical expressions which involve different operations in which they are performed is important to avoid confusion. So while doing simplification, we have to follow some rules to avoid the confusion. A standard rule is called BODMAS rule. BODMAS, BODMAS rule, where B stands for brackets, O stands for off, which means into or product, or bracket, into, D for division, M for multiplication, A for addition, S for subtraction. So brackets, off, division, multiplication, addition, subtraction. Means in same problem, if all the symbols are involved, means first we have to do bracket, means first we have to simplify the terms which are in the brackets, next which are written off between the numbers, that operations. So next they should be divided, next multiply, next addition, next subtraction. This BODMAS rule we have to keep in mind when during the problems which are involving many mathematical operations like plus, minus, into, by, like that. If it has many mathematical operations, BODMAS rule to be used. So rule 1. So here, so addition comes before subtraction. Addition comes before subtraction. Suppose we have here 18 minus 4 plus 6. 18 minus 4 plus 6. According to BODMAS rule, from addition and subtraction, addition has to come first. So this add symbol, both plus symbols we will write together, minus 4 we will write it separate. First they will be added. 18 plus 6, 24. 24. Next minus 4. Now they will be subtracted. So addition first, subtraction next. Like that only we have to solve the problem. So our second example, 29.3, 3.5 minus 1.2. Already they gave addition in group. They can be added. 32.8 minus 1.2 equal to 31.6. 31.6. So next, multiplication comes before addition and subtraction. If you have problem like this, 12 into 2 plus 4 minus 9. First what we have to do, because we have we have multiplication, addition, subtraction. What we have to do first? Multiplication to be done first. Because in BODMAS rule, multiplication is before addition and subtraction. So 12 2 times 24. 4 minus 9. Next addition, subtraction. Addition first. 24 plus 4, 28. Minus 9. Last subtraction. 19 is the answer. 19 is the answer. Here, 7.2 minus 1.5 into 2 plus 1.8. Multiplication first. 1.5 into 2, 3. 3.0 or 3. Next, addition. Plus symbols to be written together. Minus to be written in the last. 7.2 plus 1.8, 9.0. Minus 3, 6.0. Next, 1 by 2 plus 1 by 3 plus 3 into 3 by 10. First, into first. Multiplication first. So 1 by 3 into 3 by 10. 3 cancel. 1 by 10. 1 by 2 plus 1 by 10. We can take the LCM. We will get the answer. Next. Next. So division comes before multiplication. So in Bodmar's rule, division, D will come before multiplication, before addition, before subtraction. This division. Suppose if you have a question like this. So 10 minus 8 divided by 4 plus 2 into 6. So by seeing this all mathematical operations, we should not get confused. But division first. 8 divided by 4. 2 will come. So this we will simplify first. Minus will be minus only. 8 divided by 4, 2. Next. Next, plus 2. Next, into 6. Next, subtraction, addition, multiplication. Multiplication first. 10 minus 2 plus 2 6 times 12. Next, addition. 12 to be written first. 10 plus 12 minus 2. 10 plus 12, 22 minus 2. So answer 20. Answer 20. So rule 4. Rule 4. When there are brackets, the operations within the brackets are worked out first to get one number so that we can remove the brackets. So we will get one number within the bracket. We can remove the brackets and we can combine with the others. So if we get one number within the bracket, brackets are removed by multiplying the number within the bracket by the sign and the number outside. Means bracket outside if we have 2, so then in bracket inside if you have 3 plus 4, what does it mean? The inside terms to be multiplied with outside term. 2 into 3 plus 2 into 4. Like that. Like that we can remove the bracket. So this is the sign rule for multiplication. Plus into plus, plus, minus into minus, plus, plus into minus, minus, sorry, minus into plus, minus, plus into minus, minus. Next children, need for brackets. Need for brackets. Sometimes we may need to group 2 or more terms together and perform the other operations involving them before we perform some operation. At that time, we will make use of brackets. So if I have 2x plus 3 in one bracket plus or, so y minus 5, like that, I can have different values in different brackets, so that this operation to be done first, simplified first, then to be multiplied with this one. So the operations to be done first, are placed within the brackets. So here, suppose this example, find the product of sum of 4 and 8 and the difference of 9 and 7. So they are asking to find product of sum of 4 and 8. Means one group, one category. And difference of 9 and 7. Another group, another category. These two products we have to do. Means sum of 4 and 8 means 4 plus 8. Difference of 9 and 7. 9 minus 7. Product means into. Means this sum to be done separately. this difference to be done separately. After getting the values, both to be multiplied. 4 plus 8, 12, 9 minus 7, 2, 24. So addition and subtraction done before multiplication. Actually, in BODMAS rule, multiplication after addition and subtraction we have to do. But here, before product only, we have done addition, subtraction. Why means they are in brackets. They are in brackets. This brackets operation to be done before multiplication. Before multiplication. So that's why we have done like that. So here types of brackets. So here sometimes we have to group many operations. We need to use more than one kind of brackets. So that's why we have different kinds of brackets, simple brackets, round brackets, or parentheses, like this, round brackets or simple brackets. Braces or curly brackets or flower braces, like this, flower braces. Square brackets, like this, square shape, square brackets. Or sometimes a line is drawn above all the numbers grouped under it, and it is called line break or vinculum. Sometimes 0.234 bar. This part, this 234, the bar is indicated here. Sometimes. So this vinculum or line bracket is not often used. This last type is not often used. The most commonly used bracket is round bracket or simple bracket. Suppose if we have all the brackets at a time, so then how to remove them in order means first vinculum to be removed. Next, this simple brackets to be removed. Next, flower braces. Next, square brackets. Like that we have to remove. Like that we have to remove. So here, let's see this example. Interesting example. Mrs. Lal wanted to give chocolates in her class on Teacher's Day. On the occasion of Teacher's Day, she wanted to give chocolates to the students. She had 8 packets containing 12 chocolates each, and 4 extra. She now had to divide these among 25 children in her class. How much would each child get? So she had 8 packets of chocolates. Each packet is having 12 chocolates. So total how many? 8 12 times 96. Along with that, she had 4 extra. Means 8 into 12 plus 4, or 4 plus 8 into 12. When she divides this number 4 plus 8 into 12 by 25, because she is dividing among 25 children, we have to divide this 4 plus 8 into 12 divided by 25. So already one flower simple brackets are there. We will make use of flower braces. Flower braces, this total term, which is to be divided by 25. Now, this is the expression. So according to BODMAS rule, what we have to do first? BODMAS. Brackets we have to do first. 8 12 times 96. Brackets we have to do first. Again here one more bracket came. 4 plus 96. Again how much? 100 divided by 25. 100 divided by 25 means 4. 4. So like that we can calculate. So okay children, that's all for today. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.